Okay, hello. In this log, we are describing the first stage of the diagnostic method for TB detection using this sputum smear microscopy method. So in this log, we're identifying the main variables that affect this first stage and ways that we can solve this. So let's start. There are two ways to extract sputum from a patient. This is the first one, and here we have a picture describing the pipeline. So the first thing that you should do is that you should clear your mouth. An additional measure that you can take is that patients shouldn't have eaten at least an hour ago. So clean should be clean, the mouth should be cleaned, and the pharynx as well. The second, then what we should do is that the patient should breathe in and out 3 times in order to expel the bacilli to the pharynx. In this way, we can assure that sputum is fully saturated with bacilli. After that, we cough hard and we expel the sputum and we put it inside these containers that you can see over here. So I have extracted this image from the internet, and as you can see here, this is wrong. The person who is receiving the sample is not following any biosecurity measures. So as you can see, he's not wearing gloves, not even a mask, and he's using his hands to handle the sample, and that's wrong. And that's what should be avoided. And for example, in the main TB diagnostic laboratory that we are working right now, they use this reception tray in which they use sodium hypochlorite in the base, so that if any container spills out, then the bacilli can inactivate with this substance. But this is not very safe, because if you have a lot of samples over this tray, then a lot of accidents may occur. And as this is the main TB diagnostic laboratory, they have equipment, so they are wearing masks and they are wearing gloves. But in rural areas, they don't use, they only use masks sometimes because they don't have the equipment. So, and that was the first way to extract sputum. The second way is by using a catheter. This is a medical device which gets inside your mouth and inside your pharynx, and then you suctionate the sputum that is in the pharynx. So you can have a better sample because as you can see, you can get inside the patient, but the technique is too invasive, so it's hard to do, and babies and old people may not use it. And besides, rural areas, of course, do not have this equipment, just in the big cities. Okay, nevertheless, this technique is better because you have a better sample, and an important variable that we have detected in this stage is the quality of the sample. There are three types of biological sample that you may obtain using these two methods, and those are saliva, sputum, or mucus. Of course, sputum is the correct one because it's the one closer to your lungs, and with that you can assure that you may have bacilli if the patient is infected. So this is how sputum looks. Um, okay, despite what the facts that I have mentioned, mucus is also a good sample. For example, in this week, we found a sample that had only mucus. Of course, the quality of the sample was not good because it was not sputum. Nevertheless, we could detect bacilli using this mucus, but that affects another variable as well, which is called the parasitic burden. And a patient who we know that has 3 crosses, and we get a mucus sample, we may identify it as 1 cross or 2 crosses. So you will see that there is a huge correlation between the quality of the sample and the parasitic burden. So good samples determine a good parasitic burden. I mean, a correct parasitic burden, and a bad quality of the sample may even get as a false positive. I mean, as a false negative. So this is how a good sample should look like. This is a sputum. And I know it's disgusting, but this is how it looks, and this is what should be taken. Okay, so these are the three conclusions that we have reached in researching in this stage of the diagnostic. The first one is that the lack of biosecurity is dangerous, therefore better security measures should be taken. And here I will introduce something that we call an embedded device to acquire and store biological samples. And we're almost finished. We have almost finished the device. We're releasing the log in a couple of days. But the device, what it does is that it maintains a safe environment. It's a portable box with solar power, a lot of sensors, Internet of Things, and this will allow remote areas to handle specimens, slides, and a lot of different samples in a safe environment. It has also two compartments. One compartment that in which you can store masks and gloves, and another compartment in which we're planning on adding a tablet. We're planning on using an STM32F746. Nevertheless, this may increase the cost of our device, so we're not liking that idea too much. But perhaps, no, what we decided to do is to use a Bluetooth module, so you can use your cell phone to have control of the box and know how many samples, and also the app will allow you to classify patients in areas. It will be extremely useful. So, following with the conclusion number two is that a device for the collection and transportation is needed. That's the device that I've mentioned. And the third conclusion is that remote areas need additional equipment for biosecurity and organization of patients and samples. That's why we are building the tablet and, of course, the smartphone app, so you can connect easily to the. You can interact with this thing with the device that we are building. So that's it for this log.